Hi guys, welcome to my channel. In this video, I'm going to explain about the constraint satisfaction. This is the last topic in the unit 4 of part 1, and I covered the computation, concurrent process, and the histories, processes, and the procedures. Now we have constraint satisfaction. Let's see what is constraint satisfaction. In general, what is constraint? Constraint is nothing but the condition, the specified condition. So constraint satisfaction is nothing but we have to satisfy with the condition, with the specified condition. We have to satisfy with the specified condition. So this refers to the process of finding the solutions to the problem. So the problem which is occurred, so we have to find the solutions for the problem which is occurred by satisfying a set of constraints, by some set of conditions and regulations. We have to solve the problem. We cannot solve the problem by blindly. So we have some set of constraints, some set of conditions which we have to follow to solve the problem. So that only they are saying here. And it is a fundamental concept used in various fields. So this constraint satisfaction is used in the various fields like the artificial intelligence, operation research, database management. So not only in the knowledge representation, we can use this constraint satisfaction in the AI and operation research and the database management. Okay, in this also we can use this constraint satisfaction. Constraint satisfaction is nothing but to solve a complex problem, it should satisfy some set of conditions. సో ఒక ప్రాబ్లమ్ ని సాల్వ్ చేయాలంటే కొన్ని సెట్ ఆఫ్ రూల్స్ అండ్ రెగ్యులేషన్స్ అనేవి ఫాలో అవ్వాలి. సో సమ్ సెట్ ఆఫ్ కన్స్ట్రెయిన్స్ అనేవి సాటిస్ఫై అవ్వాలి సో దట్ ఇట్ కెన్ సాల్వ్ ద ప్రాబ్లమ్. నెక్స్ట్, కన్స్ట్రెయిన్ సాటిస్ఫికేషన్ ప్రాబ్లమ్స్, ఇన్ షార్ట్ CSPs, so are commonly used to model and solve the problems. Yes or no? To solve the problems only, mainly constraint classification problems are there, where goal is to find consistent assignment. So to get a correct assignment, to get a correct result of values to variables that satisfy a set of constraints. So to satisfy the problem or to solve, to find the problems, we should satisfy the set of constraints. This is nothing but the constraint satisfaction. So let's understand first what is constraint satisfaction problems, which is CSPs. So it involves a set of variables. So variables is nothing but the some objects. It can be the real world objects. So each within a domain of possible value. So it will be having some value. So and set of constraints. It will be having some set of constraints. What it will be having in a CSPs, it will be having some set of variables and some specified domains and set of constraints. So these three things are used in this CSP. So what is a variable, what is domain, what is constraint? Let's see separately. So variables are nothing but which represents entity or elements. So it's like a real world example which I said before. So it's real world object. So it's like element or item. So which represents a particular element in a problem domain. So for the certain problem, it will be having some elements. So that elements are considered as variables. So each with a domain of a possible values. So the elements which are there within a problem domain, so that elements are represented like a variables. What is the domain? So domain is like define the possible values that each variable can take. So one variable example, let's take in a Java only, like we have a like int variable, so the like array, so it will be storing some multiple data into the single variable. So we'll be having one variable where the one variable will be storing the multiple values. Yes or no? That multiple values will be assigned to the single variable. Similarly, the variable is nothing but the element for the problem domain. The domains are nothing but the value which is taken for the domain, the value which is assigned for that particular domain which we taken. So that thing. Next, constant is nothing but simply it's a conditions which specifies the allowance communications of the values for the variables. So where we'll be assigning these values to the variables. So it's some condition which specifies some connection between the variables and the values. So this is specified by the constraints. So this is the meaning of variable, domain, and the constraints. So what is the main goal of this CSPs? It is to find the assessment of the value to variables, to assign some value to the variable. Okay, that satisfies all the constraints simultaneously. So we have to assign some value to the variable, and in brackets it should satisfies the condition also. At the time only the CSPs will be working. So directly we cannot assign the values to the variable. It should satisfy some specific conditions or constraints also. Like example, if we want to take only the integer values to the specified variable, we have to take only the integer values. We cannot take the string values or the double values or the decimal values. Yes or no? So we have to take only the integer values. So that is the condition, that is a specified condition. So similarly, this is the CSP is nothing but that only. So we have to assign some values to the variables with a specified condition, some set of conditions. So this is known as CSPs. Now, how to represent the CSPs in these two ways, constraint networks and constraint satisfaction language. What is this constraint network? Let's see. And this constraint network is nothing but the graphical representation. So this is represented in the form of a graphs. So where we have nodes and the edges. So nodes are considered as a variables and edges are considered as the representation between the variables. So variables are nothing but the nodes which we have there. So edge means the link between the two nodes, simply to say. Yes or no? So it will be in the form of a graphical representation. So in this way, we'll be representing this thing. And constraint satisfaction language. What is a constraint satisfaction language? Formal language, such as constraint handling rules, which is CHR. So in the CHR is a formal language. In this we'll be having the syntax, which is a rule, semantics, which is nothing but some meaning to that, for specifying the constraint. To specify this constraint or condition, we'll be providing the CHR. So what is the CHR? Constraint handling the rules. So what will be there in the CHR? Some syntax and the semantics will be provided in this CHR. So why these are provided? To specify some constraint, to satisfy some conditions and solve CSP programmatically, to solve the CSP problems also. So no, this is a constraint satisfaction language. You have to remember CHR. What is a CHR? Okay, this is a representation of the constraint satisfaction. Now, how to solve these CSPs? So, solving constraint satisfaction problems involving finding the consistent assessment. So, we have to find the correct assessment. So, which is consistent assessment of value to the variable. The value which we'll be assigning to the variable, it should be in the form of a consistent assignment, should be correct results, so that it can satisfy all the conditions. So it should satisfy all the conditions, and it should be in the form of a consistent results. So that also we have to keep in the mind. Yes, various algorithms, techniques can be used to solve CSPs. And so to solve the CSPs, we can use the various algorithms or the techniques to solve this thing. So let's see one by one. So what are they? Backtracking search, constant propagation, heuristic search. These are the three ways how we can solve the CSPs. So first let's see what is a backtracking search. So in the backtracking search, there will be in the form of a systematic approach where we'll be systematically assigning the value to the variable. So means what? It will be in the form of some systematic order, some specified order. Yes or no? So when this backtracking will be happened, when the constraint violence is accounted. Yes or no? So mainly this is used in the form of a systematic approach. Okay, next constraint propagation. What is constraint propagation? So in this constant propagation, they will be checking the consistency. Means want to get a accurate or positive way or similar results. To get the positive results or to get the correct results, they will be checking their consistency. Because to eliminate the inconsistent assessment, to eliminate the inconsistent results or wrong results, they will be re regularly checking the consistency to give the correct results. Next is heuristic search. Here also is a checking, which is a forward checking. So it's like a consistency minimum remaining value, which is MRV. Heuristic can be used to guide the search process. So here also we'll be using the forward check. So in the consistent propagation, we'll be using the consistency check. In the heuristic search, it is also searching, so means checking the consistency. Here we'll be using the forward check. Okay, yes or no? These are the three ways to solve this CSPs. Okay, now let's see what are the applications involved in the CSPs. Scheduling and timetabling, configuration and design, planning and organization. సో నాట్ ఓన్లీ ది సిఎస్పీస్ టు డూ అప్ ఎనీ పర్టికులర్ థింగ్, అంటే ఏదైనా చేయాలన్నా ఫస్ట్ మనం దాన్ని షెడ్యూల్ చేసుకోవాలి. సో మనం ఒక టైం టేబుల్ గీసుకోవాలి, సో దట్ వీ కెన్ గో టు ద టైం టేబుల్ అండ్ వీ కెన్ కంప్లీట్ ద వర్క్ ఈజీలీ. సో మనం బ్రైన్గా కంప్లీట్ చేయక మనకు ఒక ప్లాన్ అనేది ఉండాలి. ఇప్పుడు ఏదైనా కన్స్ట్రక్షన్ చేసేటప్పుడు కూడా మనకు ఒక బ్లూ ప్రింట్ అనేది ఉంటుంది, ఒక షెడ్యూల్ అనేది గీసుకుంటాం, సో దట్ ఇట్లా చేయాలని ఒక టైం టేబుల్ అని చేసుకుంటాం. సో లైక్ ఈ 1 వీక్లో ఇంత పోర్షన్ ఆఫ్ వర్క్ కంప్లీట్ కావాలి, ఇన్ని డేస్లో ఇంత పోర్షన్ ఆఫ్ వర్క్ అనేది కంప్లీట్, అట్లా మనం టైం టేబుల్ అనేది షెడ్యూలింగ్ అండ్ టైం టేబుల్ అనేది గీసుకుంటాం. ఎందుకు ఇవన్నీ చేస్తున్నాము? టు గెట్ ద అక్యురేట్ రిజల్ట్స్, టు గెట్ ద అక్యురేట్ అసెస్మెంట్ వేర్ ద వాల్యూ కెన్ బి అసైన్ టు ద వేరియబుల్స్. ఎస్ ఆర్ నో? సిమిలర్లీ హియర్ ఆల్సో. నెక్స్ట్ ఈజ్ కాన్ఫిగరేషన్ ఇన్ ద డిజైన్. సో మనం ఒక డిజైన్ అనేది గీసుకోవాలి. సో మనం నార్మల్గా చెప్తే సపోజ్ ఒక డిజైన్ లాగా గీసుకుంటే మనకి ఇంకా క్లియర్గా అర్థమవుతుంది. ఒక లేయర్ అవుట్ డిజైన్ అనమాట. సంథింగ్ మనం ఫ్యూచర్లో ఏం చేయాలనుకుంటున్నాము ఏంటి అనేది ఒక లేయర్ అవుట్ డిజైన్ అనేది గీసుకోవాలి. అండ్ ప్లానింగ్ అండ్ ఆర్గనైజింగ్ లైక్ ఆప్టిమైజేషన్, సో వెహికల్ రూటింగ్ అండ్ జాబ్ షెడ్యూలింగ్. లైక్ ఏదైనా వర్క్ చేసేటప్పుడు వీ హ్యావ్ టు ప్లాన్ అండ్ వీ హ్యావ్ టు ఆర్గనైజ్, అంటే ఒక స్ట్రక్చర్ ఫార్మాట్లో వీ హ్యావ్ టు ఆర్గనైజ్ హౌ టు డూ అండ్ వాట్ టు డూ. So this is the applications of the CSPs: scheduling and timetabling, configuration in the design, planning and optimizing. Next is the challenges by this constraint satisfaction. So we have challenges also. Let's see what are the challenges involved in this. Combinational explosion, constraint interaction, expressiveness. So the what is expressiveness? Representing the complex constraints and the relationships which are there in the CSPs may require expressive languages and formalism. So to have this complex constraints and the relationship between the CSPs, we need expressive languages. To represent this, we should have some expressive languages, so we can perform very well. So we can, and we have constraint interaction, so we can interact in complex ways which are leading to the constraint conflicts and dependencies that make the problem difficult to solve. So sometimes the constraint which are having some specified constraints or complex constraints will be having some difficulty in to solve the problems. So this is one constraint interaction. So interaction should be very important so that we can interact with them and we can solve the problem. Okay, and combinational explosion. So CSPs often involve a large search space with exponentially many possible assignments. So we'll be having so many assignments with so many tasks which we have to perform, leading to combinational explosion. So where we'll be having so many assignments to perform. So this may leads to the combinational explosion and computational complexity. So the complexity also may increase. So this is about the constraint satisfaction, the challenges, applications, and how to solve this thing and how to represent and what is the CSP. I think you understood. Till now we completed the unit 4 part 1, which is this topics. In my next coming videos I will be explaining you the part 2, which is context. This will be very interesting. So this is about the part 1, and I think you guys understood each and every topic. If you have still any doubts, be free to mention in the comment section. I will be definitely solve your doubts. And that's it for this video. Thanks for watching. Let's meet in next video.